speaker today. In fact, our star speaker, because she's the first one we invite to Open Hardware Makers and our cohort calls. And it's Dr. Cecilia Herbert. Ceci is a behavioral neuroscience. During her PhD, she studied neural coding of song production in canaries using extracellular electrophysiology. And she has experience also with open hardware because she's been building research tools that are open during her PhD, and also started volunteering and developing open science initiatives, as she is passionate about teaching people new tools to help solve their problems and encouraging others to learn. She apparently is also a great oboe player, or that's what I heard. So Ceci, feel free to go ahead. I don't know if you want to present. Yes, there you are.
Okay.
There,
yeah. So you can see just a blue slide, right? Cool.
Yes.
Thank you so much for having me. Thank you for that introduction, Julieta. It's a pleasure. I would have loved to participate. I still have to have like a project of my own, and then I'll be here next time round. So I'm Cecilia Herbert. I'm a neuroscientist from Buenos Aires in Argentina, and I did my PhD here, as Julieta was mentioning, in experimental behavioral neuroscience, studying the brains of songbirds while they were singing. So there's a fair bit of hardware involved in that. I didn't develop any tools that I used in like any like equipment, but yes, little pieces of tools that were like specific for my implementation and to interface with other tools. And I wanted to share with you how open practices I realized were at the core of my training, and how I started this journey to share those with other trainees. So these are the kind of hardware that I was working with. This we manufactured in-house, and this I did design from an open source design that was taught to me by a researcher. These are an interface between the animal's brain. So we use electrodes, which are these tiny things. Can you see my mouse? Yes, no? So these tiny wires, yes, are electrodes that go into the animal's brain. And so this is a device that is an interface between those electrodes and what is happening in the animal's brain with the amplification system and the computer setup that is going to be plugged into this connector here. No? So in these sockets is an amplifier that is going to take this signal from the bird's brain and into our recording systems. So it's not what I'm going to talk about today, but it's the overview and the kind of work that you might find graduate students doing in the lab. So this is the setup, as I was saying. This is the animal with the wires, and you pick it up with the computer. And I was mentioning, so these are the kind of things that we manufactured in-house, and they're super small, so 1 centimeter tall. And less than a gram in weight, because we want the animal to be carrying that on its head. And that interfaces with an amplifier board that was the part of the equipment that I didn't really go into, right? That was off the shelf. But there are companies that work in doing open source hardware for this kind of equipment and the software to do these neural recordings. So the story here is that I learned this from Mariano Velucio, a researcher who was kind enough to show me everything, like building this microdrive, which is what it's called. It's this shuttle that helps you move the electrodes and penetrate the brain to record what's happening. And he loaned me the materials to get started and was super kind. There was a paper published and everything, but there wasn't a step-by-step guide or a bill of materials, right? They were doing this stuff in rodents, and I had to adapt it to make it ultra lightweight and adapt it for songbirds. And that's when I started writing that documentation, right? Being able to reproduce it made me have to write this documentation so I could teach more people in the lab. And as you can see, these were like super ad hoc stuff, like very, very specific things for a very niche application. And I felt being able to produce that tool as well as something like this thing I'm showing you here, which is a holder for the amplifier. Oops, sorry, excuse me. So this is just a drawing of another piece of equipment, again, very specific, very ad hoc, that is just holding this amplifier in a different configuration. And it was super enabling to be able to go from an idea to an actual object that I was using in the lab to help with my experiments, right? And the fact that I had those designs and that know-how, and that I was able to do it with a biologist background, right? So something that I hadn't learned during my undergraduate education. And this is how a lot of people start, at least in my field. And I was fortunate, as I told you, to have someone that spent time with me and showed me these tools. But then what about other students, right? Did they have someone? Did they even know that there was a 3D printer in the building that they could use to help them move forward with their experiments, right? And this got me thinking that the skills that we were learning, myself and other students during graduate school, were very valuable to share. And even more so if they could be implemented in the open with free and open source tools. And we set up these workshops, talleres in Spanish, talleres open source. These workshops were held in Spanish to bring the community together. We started with the neuroscientific community because that was our background. And they were about practical tools and practices in the open to make open research the default status in Latin America. So that was our vision statement that we worked just as you were doing just now. What this started with was, so I want to stress, this was me and a group of colleagues, right? But we started with some introductory workshops. So referring back to my example, there was an exercise that I taught in FreeCAD to allow students to understand how they could go from that idea to that object. It's the same amplifier holder, so this piece of equipment, but how can you manipulate it in the lab? Sometimes you need these super simple parts. But they didn't have any electronics or interacting parts or more complicated stuff that you're probably designing now for your own projects, but it was still enough to get a grasp of the open development cycle. And we did this not only with hardware, but with, with software and other stuff. I'll show you that in a minute. This is about that open development cycle. Is okay, one of the students that took the course adapted what I taught them and did it for this. This is the same kind of container for the amplifier right here, but it's a watertight, and they are doing it instead of rodents or canaries, they do it in crabs. So of course, having this knowledge and having been able, it's something that could be seen as very, very simple, but this is an essential tool in this person's workflow now, again. So we really, like sharing and teaching these very small parts had a wider reach than I could have imagined. And really, you don't know where the designs could end up, right? They could be on top of crabs in a lab. So the project involved, as I was saying, not only hardware, but software. So there we have like Python, graphical analysis, or bioimaging, tracking animals, some motor stuff. And these are all the tutors that work with us. So it was people such as myself and other graduate students that, knowing a subject that they had to learn during their PhD, they opened up that knowledge and gave practical lessons on how to get started with that. So starting with the simple stuff, right? Or the introductory, because it might not be simple to anyone else, right? And these were virtual encounters and in Spanish. And we uploaded everything to YouTube, and that meant that we could be inclusive of people that couldn't come to those time slots. And we also took into account their interests by giving surveys and surveying what their needs were and how they were going to interact with our content and the content that our tutors could provide to us. We participated in the Open Life Science program, which, as you have heard, is very similar to the kind of stuff that you're doing here. And really, I have to say that working on our vision statements and adopting licenses and the code of conduct, it really made the project more welcoming and especially more transparent to people and how we were leveraging other people's work to provide our training, right? And it meant that our stuff started to be open by design instead of as an afterthought. So it's a vision that is clearer to potential collaborators, to students, and even to present ourselves more solidly with grant agencies. Basically to allow us to get more people on board with a similar mindset and goals to our own. In terms of these grants, what we received was a very generous funding from an international organization to allow us to embark on an ambitious 5-day-long training in which we were actually able to send hardware out to people across Latin America. And really, even though there's a whole ecosystem of tools in our domain that are open source and interoperable and give you control of every part of our experiment, usually at a lower cost. What is also something that people have not maybe yet been taught is that to broaden that concept of open source, not just to your tools, but to your practices and to these small iterations that you make, such as the little pieces of specific equipment that I was printing out and someone adapted to crabs, right? We were able to use open material because that had licensing that was open source. It was worked by specialists and pioneers in these open source tools, which we translated to Spanish and adapted to our needs. So I was also a big part of working in the open to be able to leverage on these things and adapt them. Students were really thrilled. I mean, we found that there was not necessarily a literacy in basic programming and electronic skills, even at that level for the kind of public that we had. And this was tremendously enabling, and they knew that they could share this with more people because it was open source. In the training materials were open source. And to us, the organizing team working in the open also meant transparency and accountability. We talked about in the course who we chose, why, in terms of gender equality and different geographic distributions, and also had front of mind that we wanted to share this with more people, and now all of that material is online. So I think that at the core of building open is sharing, right? And I really wanted to stress that there is value in taking the time to document your project, even provide training to be able to engage with your community and understand them and better share your open source projects. And like each person that gets to your landing page or to your GitHub or to your talk for the first time is new to the project. So like that dance that you're dancing is new to them, even if the music can be familiar, and you kind of have to bring them in and invite them to dance and show them those steps to that dance so you can dance together, right? People come with different skill sets, different interests, even different languages, as was a main focus in our project. And I think it's useful to have like a starter pack of what you need to know to get started and where those expectations are. Just a brief anecdote, when in one of our courses, I have this here to remind me. So I'm showing the jumper wire, a bundle of jumper wires. And a student was having problems. Okay, they had to connect a basic circuit, and they had, okay, which wire do I have to use in the bundle? And all it took as an explanation was like, okay, like these are actually individual wires, and you can use one of them at a time. Like this is not a component, this is just what we gave you in the kit, but this is how they're bundled up together. You can choose just one. And that's all they needed to get started, right? All the rest of it wasn't a problem. It was just this thing that for someone with the bias of having done it already was very, very obvious and not a problem at all. So I would invite you to think what is going to be the jumper wire bundle in your project, and what is one small thing that you can tell someone that can help them adopt your project. And I think there's nothing that's too small worth mentioning, within limits, of course, but in the sense of, you can also set your expectations and say, yeah, well, okay, people building my project will have to know how to use jumper wires, whatever. But where is that limit, and how can you anticipate those needs and be aware of them instead of just shoving the documentation online and hoping for the best, right? And I think that is sharing, and it's a vital part of a good open source initiative. So that was it for me.
Thank you, Ceci. That was great. That was, I think, exactly what we needed to discuss today at the very beginning. Does anyone have questions or comments for Cecilia?
I would go ahead. I found the last part especially interesting, because I think this is what you could also call opportunities, right? Because people connect for different opportunities. Like you go together to the bakery, the one just wants to smoke, the other one wants to get bread, the other one just wants... So like, okay, but we're all going to the bakery. So this is, if you look at it, not everybody is passionate for the same reason. Not everybody is passionate for bringing drinking water to people who can't afford it. Some people just want to have fun. Also, that was a key part of Linux success, what I read now. It's like, okay, it was just, okay, we're having fun, and it's totally all right. So yeah, it's really important, and I like the image with the different wires. I'll keep that one. How to kickstart, bring the spark.
Sheldon, I think you're muted.
Yeah, just a question. What would you say was a good first step for you to start really sharing your documentation and engaging with people, like bringing them in, sorry.
Yeah, thank you. I think it was having these events of gathering people together, and because they were at the training, like events with different topics, and we took some time to show them the platform, which was on GitHub. But GitHub is sometimes intimidating to a lot of people. So part of it is also like having a workshop on what GitHub is and how you can move around your documentation. And then again, it doesn't have to be a special event. You can maybe record a video and have it there, like at the beginning. This is what our project is about, and where the things are and how these things interact together, like a little map. And for us, it was a translation of the material as well, because it's something that is alienating sometimes when you have to learn a new subject and also learn like in a different language, even though most scientists use English, of course. This was like an extra step to bring them closer. And we had a website as well, like to have a different format. I can actually show that, right? To have a different format from YouTube. This was made with the Hugo templates. I hope you're seeing it now, the workshops, and it's deployed from GitHub, and it's very simple. Actually, it's not, doesn't look amazing, right? But so we have what the project is, and this same kind of vision statement that I was telling you about, and then like links to the platform. So if you want to see the videos, they're on YouTube. If you want to see the materials, they're on GitHub. The people, of course, that we're working with. And then for the GitHub, and this was through working with the Open Life Science program, right? Of course. Very front of mind here, read me what this is and where you can find stuff on YouTube, Discord server, conduct code, and the licensing. And I think with that, it's a very first. I think this is missing. Okay, how you can contribute? We're still working on that, right? So it should also have a statement of if you are taking people contributions and how to do that. That's what. Yeah.
This is good because as part of the module 2 that we are seeing today and we saw last week, we suggest you to start. Some of you already have like a website, but we suggest you to start turning this vision into this introduction to the world. I think, Ceci, if you allow me the interpretation, I think for me the most relevant thing I got from your presentation is how well you know the users of your project, and you brought them by developing these workshops. You kind of had an idea because they are students working on similar things, but maybe not. So they have like the minimum necessary information to take on from there, but you know who you're talking to, and I think that's super important.
Yeah, we also purposefully surveyed them. So we asked them, do you work, do you know open source tools? Do you work in open source tools? Are you interested in open source tools? And then which ones? And also always tied to a particular example in mind. So such and such software for tracking in neuroscience. So a very, very specific set of problems. Maybe they don't know the tool, but they know the problem that they have. So maybe that's an approach you can take as well. Like, what is my tool solving? And maybe I can tell people more about that problem, and then it will become obvious how you need that tool to solve that problem. Yeah.
And another thing is that the website is very simple, but it tells you what you need, right? I don't know if it happens to you, to the rest of you, but when you go into a website and you're trying to understand what this is about and what you can do with the project, and it's so crowded with information that you don't know what to do, it's very frustrating, right? So even as the simplest website with actions for the user to visit YouTube or download the documentation, I think that's